Hello there and welcome to this course on statistical data analysis with Python. My name is Valentine and I'll be your instructor for today. In this course, we are going to be following the following agenda. So we'll start off learning about the learning outcomes of this course, then get to understand what is statistical data analysis, understand what concepts are we going to be learning, why do we apply those concepts, as well as when and where do we apply those particular concepts. Once we have completed that section, we'll go into another section where we will go through a reading and a quiz. And the reading will look much more like this. This is a quiz of the reading for this particular um, course, and it will provide you with in-depth details about the concepts that we will have gone through in the first in the overview section, where we talk about what why and where we can use those concepts. So you go through this reading for about 10 to 15 minutes. Then after that, you will go through a quiz that will just generally test your understanding of those particular concepts that you will have gone through. Once we have really gotten a hang of the theoretical aspects of statistical data analysis, we will then go into our practice work, which should take us about an hour or so. And for this practice work, we have curated content in relation to statistical data analysis. And this content will have examples as well as challenges that you can be able to go through in order to generally acquire that that skill pertaining to statistical data analysis that will be important when you're working on data analysis or data science projects. So you will be able to go through that experience of practicing. I'll be also taking you through this. So you go through the examples and then work on the challenges. We've also provided some solution notebook document that will contain the challenges, the solution to the challenges that you will have gone through. So for instance, in our case for measures of central tendency, you see that there are challenges here, but at the same time, you also have challenges, the solutions to those challenges in this case. So this particular part of this course will give you some hands-on practice, and you should feel that you are gaining the most from the learning experience. Once we have completed the practice work, we'll give you a project statement that you will continue working on by yourself. So this is the project that you're going to be working on, a real life project where you put into practice what you will have learned um, in the practice work as well as in the reading and before, and you will be in a good position to say that you can actually solve a real world challenge or problem when it comes to statistical data analysis. So once we have completed that, once you've completed that, which you will do separately from this course, we will provide a solution notebook, which will just generally contain just a sample solution to what you would have been expected to have done in relation to the project, which will have given you. Additionally, to give you some extra support, we also have a guiding notebook that will give you just some steps on how you can be able to achieve the project itself. So there you have it. This is a really intensive learning experience, and I hope you'll gain the most from it. And the idea is to ensure that you will come out of this particular workshop having been having acquired these skills, which are critical when it comes to working on any sort of data analysis or data science project in relation to statistical data analysis. So let's get started. All right, starting us off, the first thing that we're going to be learning are the learning outcomes for this workshop. By the end of today, you will be expected to have achieved these learning outcomes. You will be expected to explain and calculate the measures of central tendency. These are just ways that we use to understand the central point within a particular data set. It could be mean, understanding the mean of a data set, median, mode, etc. You will be expected to also be able to identify the strengths and weaknesses of the measures of central tendency. You will be expected to explain and calculate the measures of dispersion, how well spread or how spread the data points are within a data set. Be able to identify the strengths and weaknesses of measures of dispersion, identify and describe scatter plots and line graphs to determine the relationships between two variables, and lastly, be able to calculate and interpret the Pearson correlation coefficient to determine the relationship between variables. So those are our learning outcomes. So by the end of this particular workshop, you should be in a position to come back to these learning outcomes and to just assess to what extent were you able to have achieved them. Starting us off, what is statistical data analysis? So statistical data analysis just generally involves the type of analysis that you would perform that involves various statistical operations, and the goal would be to identify meaningful patterns within a data set that will be important in your further analysis. So normally we would perform this type of analysis when we are working towards, in most cases, deliverables pertaining to training of machine learning models that we can use to make predictions. So when it comes to creating machine learning models, which are generally programs or just programs that we create to make predictions, we normally perform statistical data analysis at the very start. On the far right of your screen, you can see that there is an image. This is an image that gives us an idea of how we can be able to achieve a project, more so our project in relation to machine learning. And we normally start with business understanding, data understanding. We understand the data. Business understanding, we normally have, we try to understand the question that is at hand that has been proposed by business stakeholders. Then we get data and we try to understand the data. We prepare the data. We perform modeling, which just entails training your machine learning models, creating and training them. Then we evaluate them and check whether they actually were able to have met the metric of success that we have for this particular project. If not, we go back and we again figure out a way of making sure that we meet our metric of success, which might mean again maybe sourcing for some new data, maybe performing different kinds of data operations during data preparations, etc. We go through the same process and up until we have gotten a satisfiable solution that we can use now for deployment. So that usually is the stage. And during statistical data analysis, during actually the whole process, we would perform statistical data analysis during the data exploration phase, which is actually what you see here. No, actually, what you see here, data understanding. And to break that down further, that is when we would be performing something like data exploration within a data set. Once we have pulled in data that we want to use loaded data that we want to use for our analysis, we then would perform statistical data analysis, which usually comes in multiple forms. There's univariate analysis and bivariate analysis. There's also another type of analysis called multivariate analysis, but these are just types of statistical data analysis that we tend to perform and would help us ensure that we have a data set that is in the best shape for further analysis. So it could be that we might ensure that our data set is in the right format in a way that we can be used for training of a machine learning model. Then once we have discovered insights, we have made observations, then we can perform various data preparation techniques to put that data set into the right format and then perform data analysis, modeling, and then later onwards present our solution to our stakeholders. So I mentioned that different types of statistical data analysis. So there is univariate analysis, which is usually the most simplest form of statistical data analysis. And when we are working with univariate analysis, we tend to work with one variable. So when it comes to working with data, just to give you a macro view, we normally pull data from different sources, or even could be just data from one particular source. And that data can be in the most common format, which is tabular structure. And in a tabular structure, you have rows and columns. So the columns would be referred to as variables in the context of data science or data analysis. And the idea normally would be once you have loaded your data set, you want to understand the patterns within the data set so that you know whether that data is suitable for further analysis. So it could be that you might want to explore the individual variables, like individual columns. And that process of exploring the individual columns, like understanding the individual columns or variables in our context, would be what would be referred to as univariate analysis. If we are working with two different variables, so if we want to find out maybe whether there's a relationship between two or more variables, then in that situation, we would be performing bivariate analysis. We would perform and we would create scatter plots, which are just visualizations that help us to understand whether there's a relationship between two variables, or other types of visualizations that would help us understand how two different variables are related to each one another. So for one particular variable, we perform univariate analysis. For two variables, we perform bivariate analysis. For more than two variables, then we perform multi-variate analysis. And this is just a more complex form of statistical data analysis that we can perform. Our major focus for this workshop, for this course, will be univariate analysis as well as bivariate analysis. So going a bit more in depth with regards to univariate analysis, we've already gotten an idea that we tend to work with just one variable, individual variables, when we are performing univariate analysis. So we might decide to perform univariate analysis on the age column alone, or the height column alone, or the salary column alone, or the income column alone. So univariate analysis would perform on those individual columns, but so that's what we would do. And the types of techniques that we would employ in order to perform univariate analysis would be creation of frequency distribution tables, histograms, pie charts, bar charts, box plots, um, um, using measures of central tendency like calculating the mean, median, mode, or even also using measures of dispersion, like understanding how spread out the data is. It could be, might want to calculate variance, range, IQR, which is the interquartile range, or standard deviation. So these are different techniques that we might want to perform in order to understand our data set really well. And sometimes the reason would be, sometimes we might realize that later during our analysis, or during later further analysis, where possibly we might want to create machine learning models, we might foresee that we would want to use maybe a machine learning model, a specific one, such as linear regression, that tends to require that the data that is being used for training of that model be in a particular format. And it could be that we would need to ensure that based on the linear regression assumptions, could be that we would need to ensure that each and every variable has a normal distribution, because that's what that model, that's linear regression model, requires of the data set that we would use for training. So performing these techniques would ensure that some of these techniques would actually ensure that we are able to ensure that we know that the data set that we are working with isn't in the right format, or it's in the right format for further analysis. And if we realize that possibly some variables are not in normal distribution, which is one of the assumptions of linear regression, then we can either decide to employ some other techniques to ensure that those individual variables are in normal, have a normal distribution, or we could even decide to leave them out from the training data all at once. So, but that's just an example for histograms. For something like if you wanted to also understand whether our data set is balanced, which also has implications on how a data set, how a machine learning model performs. So, for instance, if we wanted um, to train a model based on respondents' data, so in order to ensure that our data set isn't biased towards one particular group of respondents, maybe one particular gender, we would need to ensure that our data set is well balanced. So we might want to ensure that in our data set we have 50% records belonging to one particular category and 50% belonging to the other category. Say in the case of gender, if our data set has 70 records of one gender and 20 records of another gender, and we use that data set to train that machine learning model, it's likely that the machine learning model will be biased towards the records which have a higher category than the other. So by the way, the category we would normally refer to it as a class. So the use of something like a frequency distribution table would just give us an idea of how that would look like. But even going further, to create something like a pie chart or even a bar chart would actually visually communicate that this data set is not balanced. So we need to ensure that we source for further data that would ensure that our data set is balanced. Or we might even perform other techniques such as what are called upsampling, downsampling, to ensure that we have good records, good amount of records which are fairly balanced, that will ensure that our machine learning model is actually performing to par. It does not make, it's not biased towards one particular class or category. So these are just some techniques that we would tend to perform. Box plots, if you want to check for outliers, they usually come in really handy as well. So we'll get to practice these ones, these techniques in the practice work, which will be coming in a few. So looking forward for that. Now, bivariate analysis, on the other hand, is a type of analysis that allows us to understand the relationship between two or just two different variables. And we can use techniques such as building scatter plots or line charts to just understand how one variable changes with respect to the other. Or we could even calculate what is called a Pearson correlation coefficient, which is just generally a numeric figure that usually lies between -1 and +1. At the center, it is usually 0. And values which are values of variables. So if you, again, bivariate two variables, if we calculate the Pearson correlation coefficient for these, let's say two of these variables, and we realize it's closer to 1, then we tend to say that those two variables have a positive correlation, or they are highly positive correlated. I mean, they are all closer to 1. So it means that as values of one variable change or increase, the other values of the other variable also increase. So that is usually on the, or an interpretation of that. And then on the other end of the scale, where there is -1, if our correlation value is maybe -5.2 or -6 or minus 0.5, -0.6, -0.7, almost towards 1, -1, then we tend to say that our two variables are have a negative correlation or they have a high negative correlation, which means that as the values of one particular variable increase, the values of the other variable decrease. So in both cases, you have some correlation between the variables. If the value of the Pearson correlation coefficient of if any two variables are closer to 0, are closer to the center, then we tend to say that those two variables have a weak correlation. Could be it could be either a weak negative correlation, so somewhere between -0.5 and 0. That's a weak negative correlation. If it's from 0 to negative, from 0 to 0.5, that's usually a weak positive correlation. But the idea here is just to be able to represent the strength of correlation between two variables using a numeric figure. And that's important in ensuring that we are able to narrow down really on to what degree are these two variables correlated as well. So we'll get to also be able to work towards creating a Pearson correlation coefficient and also create a visualization that's called a heat map to also just visualize and communicate our insights much more clearly. So that is with regards to bivariate analysis. On the multivariate analysis side, this is again on the other side, this is a more complex form of statistical analysis techniques, related techniques, and we would normally work with more than two variables. So if we wanted to possibly decide to represent, if we have a bigger data set and we wanted to represent multiple variables using some other two or three or four lesser variables. So if we had a data set with 100 variables, like 100 columns, and we wanted to represent those variables with maybe 10 variables instead of the 100 of them, then we can be able to perform multivariate analysis to be able to do that. We can also be able to perform different types of techniques: factor analysis, cluster analysis, discriminant analysis, multi-dimensional scaling, etc. So these are techniques that would require just whole courses on dedicating on them. So we won't really go so much deeper into this, but the idea is that you just have an idea that multivariate analysis just involves working with more than two variables. Our focus will be univariate and bivariate analysis because in most cases that is sufficient enough to work on any data science or data analysis projects when it comes to machine learning or even when it comes to creation of reports. So again, just for a recap, why do we use statistical data analysis? If we want to identify trends, patterns, and relationships in data, statistical data analysis comes into play really well. If we want to create descriptive statistics to provide maybe a snapshot of the data characteristics, then that's a good use case. If we want to generalize findings to draw a conclusion beyond the observed data, we can still perform statistical data analysis. To support evidence-based choices in various domains, maybe in healthcare, business, policy, again, we can still perform this type of analysis, which might be just quite important, and it might just help us to just understand what's happening, to detect anomalies or deviations from expected standards. Statistical data analysis would come, maybe using box plots, even doing a calculation such as IQR, that would come in handy. To make predictions based on historical data and patterns, then we can also be able to use statistical data analysis. When do we perform this type of analysis? What type of projects? When we're working what type of projects? So if we want to create reports and dashboards, we can generate descriptive reports using these methods that we're going to learn. If we want to create just simple visualizations without even thinking about further analysis, then we can use just these statistical data analysis techniques that we've mentioned. Again, statistical summaries, such as maybe we want to identify what is the mean, all those measures of central tendency or dispersion or distributions. Then again, statistical data analysis techniques would be handy. When we want to predict models, when we want to create machine learning models, in order to ensure that the data that we are working on is in the right format for model consumption. So again, statistical data analysis techniques would come in handy. So yeah, so there you have it. This has been just a short while of a macro view of what statistical data analysis techniques entail. The next thing that we're going to do is to go through an in-depth reading and quiz which would just generally explore those concepts that we've talked about much more in depth. And the idea is for you to have a good, firm understanding of those techniques and be able to assess, be able to um, 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 assess your understanding of those techniques in by using of this particular quiz, by just using this quiz to just check on whether you're really able to understand those concepts. And once you have been able to do that, once you have been able to go through this quiz, then that should be evident enough that you are ready to now undertake the next steps, which is now applying now those concepts, the theoretical concepts that you have learned using Python. You don't need to just learn the theory bit. Again, you need to also learn the practice aspects, because that is what you're going to be doing in your line of work. All right, so let's you can pause this video and then come back once you have gone through the quiz and reading. All right, see you in a few. All right, so now moving on, I forgot to mention that the resources that you're going to be having for this course are resources that you can get through a shared link that we've shared in the description section. And for persons who just want to learn and not necessarily to immerse themselves, there's a sample solution, not a sample solution, sample practice notebook that you can access and be able to go through. Unfortunately, we haven't provided the resources for persons who are not Afterwork members. Afterwork is just an organization dedicated to just helping working professionals acquire tech skills. And we haven't done that for other members, but if you want, we have a small fee that helps us to just keep just things running. So feel free to do that, and you just get access to all content that you would want from our database. So generally, that is something to note. So if you want to learn a bit more, just consider that. But if you are looking towards just going through this video course, or even just run the examples that we have, we've provided a sample practice notebook that will allow you to be able to just follow through, which you can just open and also follow through with what I'll be doing. So moving on, so the next step will be just to access the practice notebook, which will contain would actually contain the different concepts that we've covered so far in relation to univariate and bivariate analysis. This notebook, it's just a document that we've curated, and a notebook is a document that data analysts or data scientists use to be able to share their work with other stakeholders, such as fellow data scientists or data analysts. So we have curated content in relation to univariate analysis and bivariate analysis. And for each concept, you have examples as well as challenges that you can be able to go through. So once you get to this page, the first thing that you need to do is to save a copy of this notebook. This is a master copy. It's one that everyone has, but in order to make changes and save those changes to your Google Drive, you need to go to File, then Save a Copy in Drive, and then it's going to open a new tab with a copy of this particular file. So what you will need to do is to you can rename that copy and be able to now make changes and save those changes. And whenever you need to go back, you could always just go back to that notebook and you'll find your changes already provided there. If you're looking towards just going through the notebook without any changes, you can just run as they are. You'll get just a prompt that tells you whether you want to run anyway. Just click on that. But yeah, so I think that's basically it. So I think that's just a quick intro on what that entails. So we'll get started in this notebook. We usually have code cells and text cells. Code cells just contain code, and text cells just contain just text that we can be able to contain and provide explanations to the code that we have. So getting started, the first thing that we do, go File, Save a Copy in Drive, which should open that and should be good to go. Or just go to playground mode. Just ignore what I've done there. I just opened mine in playground mode. I don't want to make a copy to the actual notebook, because you also have access to it. So once you get here, the second thing that you need to do is to connect. Click on connect on the far end to connect this notebook to Google servers. Our notebook will be hosted on Google Drive and Google provides an application that allows us to interact with notebooks, just called Google Colab or Collaboratory in full. Through that application, we can be able to run our Python code on the web, not necessarily on our computers. So once you have connected, you should see there's a check icon. So we will expand now the prerequisites section, and we are going to import libraries. So libraries are just a chunk of code that has been written for specific purposes. There's a library now. In a programming language, you have libraries, which are just code that has been written for performing specific tasks. You have visualization libraries, you have data manipulation libraries, you have machine learning libraries, you have like even specific libraries like performing scientific computations or even working with text, etc. But for our use case, we are going to import 4 libraries, which is just chunk of code that has been written and well tested by other people. There's pandas, which is the Python library for performing data manipulation or data analysis tasks. There's NumPy for performing scientific computations. So if you want to perform conversions, maybe from integers to floats, or even just perform aggregate functions such as sum, min, max, pandas can, NumPy comes in handy. Seaborn allows us to create statistical distributions. So if you want to create what are called pair plots, which just enable us to see, it actually provides us with a collection of what are called scatter plots that enable us to assess the relationships or to check the relationship between different variables in our dataset. Then Seaborn comes in handy. There's matplotlib, which is just a basic data visualization library in Python. It's usually the starting point when it comes to just working with visualizations in Python. So let's import those 4 libraries by clicking on the icon there. I was mentioning that if you see a pop-up, just you need to go and save by going to save and file save in Drive. But if you don't, it's okay. So click on that icon and you should see a check icon once that has been imported. So it means here that in any place that we see in our code, we have written NPD, NP, SNS, PLT, we're going to be referencing these respective libraries. So once we have done that, let's click on this icon over here to just expand, and we work on frequency tables. Starting off, that's univariate analysis, frequency tables. So we can create a frequency table, which is just a table that calculates, that shows us a summary of the counts of a particular value within a particular column. So for instance, let's load this data set and preview it. So we'll load the data set. This is the data set that we're going to be working with. It looks like this, has just records about age, gender, job, housing, saving accounts, checking account, credit amount, duration, and purpose. This is just a loan. I think it's just financial data set. So we save this data set inside this variable credit df, and then we preview the first 5 records using the head method. We apply this method or the head function onto our credit df variable, or in pandas we call it a data frame. So if I run that, I will be able to see the first 5 records for the data frame, which should give us an idea of what's happening. Then we create our frequency table. So we click on, well, you can click on this icon, but the idea here, to create a frequency table, you need to use value counts function. You apply this to the actual column that you want. So credit df is the data frame or table. Data frame is a tabular structure when you're working with pandas. And then we reference the column that we want. We want to perform our calculation or apply this function on this particular column. And we can actually do it also on these other ones. Only that we want to focus on the sex column. So yeah, sex variable. So we have this frequency table, which we have here, male 690, female 310, which just generally means that there are more records, male records than female records. So in some situations, if you want to create this data set generally is not balanced, because that is something that's important. You might find that your machine learning model is biased towards men than female, or even female than men. If you realize that female, the respondents here are all have all um, sort of higher values for certain variables, then you never know what happens. So yeah, so work on the challenge and then verify your solution using the solution notebook that we have here. And once you're done, then we will continue. So this is the solution notebook under frequency tables. You can do that. All right, moving on. Bar charts. Bar charts are visualizations that we can use to display, again, a frequency distribution table visually. So so assuming that we have decided to create now a different frequency distribution table for savings accounts, so saving accounts, which is there, we can be able to plot a bar by simply using the plot function and specifying the kind of bar that we want. We use the plot function kind and bar. But now we're using pandas to create our bar chart. We are not using matplotlib or seaborn, which we could also use. But this is just a quick way of creating a bar chart. And we can see that this is how our bar chart looks. All right, moving on. Histograms. By the way, work on the challenge before we move on. Work on the challenge that we have here and then verify your solution using the solution notebook. Moving on to histograms. So histograms allow us to understand the distribution of data within a particular variable. So you would have bars of different heights and you would have what are called bins. And this would tell you whether there are, it would just generally give us an idea of the distribution, whether the data set or the data that you're working with, or the variable, which is one, we're working on with one variable, we are performing univariate, and whether that variable is uniformly distributed or has a normal distribution. So in our situation over here, but before I even click here, so we're using PLT. PLT is Plotly. So PLT, we're using Plotly, not Matplotlib, sorry, Matplotlib. You're using Matplotlib. Plotly is a different visualization. We're using Matplotlib, which is PLT dot hist, the hist function from Matplotlib, and then we pass the column that we want to perform this operation on. So as the first argument, then the second argument, we define how many bins that we want. Then we describe the type of histogram that we want, a bar, and then we also describe the width of those bars. So let's do that, and we can see in our situation that lots of points actually lie on this other side, that's on the lower side of duration, than on the upper side. So lots of points, especially around 20. We have quite a number of points. 20, 21, actually 21. We have quite a number of points. So our points are distributed much more towards this other side of the scale when it comes to duration than on this other side. And these are just observations. Like the highest occurrence of duration is around 22 months. The histogram illustrates a positive skew, so this skewed positively. So generally, this would mean that there's a longer tail on the right side of our peak, and for this reason, the mean is usually larger than the median duration, and most of the duration is between 18, just 18 over here, and 24 months. And again, people can make just conclusions generally about that. Might even decide, maybe if you realize that your highest, or if you do some analysis, especially for the expenses, and you realize that people tend to spend more on a certain across a certain range, then you can always make some decisions based off of that. But not only just that reason, could be many other reasons. All right, work on the challenge and then let's continue. Then verify your solution and then let's continue after that. All right, moving on. Pie charts. Sometimes we might want to display the frequency distribution without using a bar chart. We might want to use a pie chart, which will just give us the relative contribution that different categories contribute to the overall total. So we would first of all decide, let's first of all decide to create our frequency distribution chart, which we have, and that data we store in credit savings, and we can preview that data as shown. So we have, for saving accounts, we have little, moderate, quite rich, and rich. And then we can be able to, again, if you want to, we might want to ensure that we get this label, the labels for the chart. Sometimes you might want to identify each section within a pie chart using what are called labels. So in our situation here, we are extracting little, moderate, quite rich, and rich from credit savings, from the output of this particular operation, using this two particular this line of code. So index to list. This just converts two lists, converts whatever that it's applied to as a list. So for instance, here we are accessing the index, which is of credit savings, which is little, moderate, quite rich, and then we apply to list to just convert to list, to convert to a list, which is a Python data structure, into we are converting that into a list, and then we store that in labels, and we should be able to see now we have this list, Python list. And then we use matplotlib .py, the py function in matplotlib. Credit savings is the first argument. Labels it's what we have here, and auto PCT to just define that we don't want any decimals in our chart. So this is what we have. And you could also decide to even just uppercase what you have here, so that these ones appear quite they look quite well here. And you can even decide to explode different sections, but that is something that we cover in a different workshop that's in matplotlib, data visualization with matplotlib. You can check that course on our website if you want really to, on our we have provided that course as well, so you could always refer to that course if you want to learn more how to even style these charts. But yeah, but the idea here is to create a pie chart and make some observations, which you can. All right, so work on the challenge, and once you've done the challenge, verify your solution, and then we can continue. All right, box plots. So box plots are a type of visualization that we use when we want to do two things, actually three. When we want to identify whether there are outliers within a data set, when we also want to understand the distribution of our data, and also when we want to identify the center, the center of our data. So to be able to work with a box plot, we normally we can use matplotlib or Seaborn, but Seaborn usually comes in really well. So for instance, the Seaborn way would be use SNS, then box plot function, then we pass the column that we want to now the box plot function, and that's generally it. And you should get a box plot that you see here. And from our observation, we can see that the points that are outside our box plots are actually they're actually points here, which means that there are outliers within the duration column. In addition, we can deduce that the median of our duration is roughly 18. So in our box plot, we have this box at the very center position, but the central point of that box, if we can extrapolate that, comes towards around 18, 19, 18, around there. So the median, which is usually the median, is representative of the median of our duration is around there. The minimum recorded duration would be 4, because this particular this t, the one that you see here, and when you extrapolate that and you look at the x-axis, you would actually see that it goes towards something like 4. The highest is actually a 72, which is quite high. So generally, 75% of duration was above 24. So 75. So normally, the half point of our data set usually would be from here. So actually no, from here, but 75% was above 24. So this is the 75th percent, 25th percent, 50th percent, 0 to 25 here. So 75% of the duration from here up and above um, 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 was above 24, and but 25% of duration was below 12, which is right over here. 50% was around from 12 to 24. Yeah. So the 75%, like by the 75, by the way, we mean that the points which appeared um, um, from the 75th percentile um, were from above 24. Yeah. All right. We can also decide to get more details about what we are seeing here. Right now, we're just using our eyes to just understand what's happening. Sometimes you might not have the exact details. So to be able to get the exact details that we have even just mentioned here, median, 75th percentile points, 25th percentile point, minimum and maximum points, we can use the describe function, sometimes called method, and we apply it on the variable that we want. So we can see here, we had 1,000 points count, just means 1,000 points. Mean was 20.9. We don't have a mean here. Here we have a median. Standard deviation 12.05. Minimum, which is a 4. 25th percentile, which is this line over here, which is uh, which is it was it 12, 18, at 18 over here we had the 50%, 24 at 75th percentile we had 24, and maximum we had 72. All right, work on the challenge and then verify your solution using the solution notebook. Then we'll continue to measures of central tendency. All right, moving on to measures of central tendency. We might want to understand where exactly within our data set is the most central point for the data sets that we want. Sometimes we can, the reason we might want to calculate such measures would be because maybe we might have missing values in our data set, and it might be important for us to just replace those missing values with some value that is much more central to all the values that we have in our data set. So that might come in handy, and a central point for different use cases might be using maybe a mean in certain cases, median in certain cases, and mode in certain cases. This is a workshop that we can cover in handling missing values. That's also another course that we have done, by the way. So we can still do that. But let's see how we can work with what we have. So mean. So understanding how to calculate the mean for a particular variable. So how do we do that? We first of all define the variable or the column that we want to reference. That's the age column. That's how we define it. And we apply the mean function to that column, and that will give, and we save now the output of that, which is the mean of that particular column. We save it into mean age variable, and then we can print it out, the actual variable, and then also a round of that particular variable to get an answer. We round off to the nearest whole number by just setting this to 0 and using the round function as shown. So for that, we'll get 36.0. Actually, here we are getting a float, which is okay. So our mean for that data, our mean for that column was 36. We want to do the same thing for median, the most frequently occurring point. We can be not the frequency is actually mode. Median is different. So to calculate for median, we can do the same, but now use a median function. So like that. And for mode, which is the value that occurs most frequently in the data set, we can use mode, and then we use ilog to be able to get the output of what we are going to be getting. Because if we don't use that, so let me just run this, and you should be able to see we get 0 to we get 0 then 27, but in order to access now the 27, which is actually what we want. We just use the iloc method, and we are able to get 27 as the most frequently occurring value in our data set. But again, we can also still query. Sometimes you might want also, aside from what we have, we could even decide to now, actually, let me just explain a bit something more here, which I think I might have overlooked. So here we're getting the 27. Age is equals to 27 is the most occurring. It's the um most frequently occurring value in our age column. But sometimes you might want to retrieve the actual records for where maybe um the data frame has those records are. So to be able to retrieve, let's say, those records with the most frequently occurring value or age, we can do that by saying credit. Then we use the query method, and we use an expression. We say in quotes age, which is the column, is equals to 27, and we should be able to get that. And these records, quite a number of them, have ages 27. You can see the age here is 27. All right, work on the challenges, and then once you're done, you can come back and we can continue. Remember to verify your solutions. All right, moving on, measures of dispersion. Sometimes we might want to understand how spread the data is in our data set. And this might be important in specific use cases. And this is more like finding knowing whether the data is much. It's actually more like for creating a histogram to understand the distribution. So sometimes you might realize that if you use, maybe if you decide to to use the histogram way, that might be if you want, that might work well for you. But sometimes you might want to also just understand how well spread out the data that you're working with is. Sometimes values could be closely towards one particular point over other values or variables which are much more spread out. But to start us off, variance is just a measurement of the spread between numbers in a data set. So it just measures how far each number or data in the set is from the mean. So so yeah, let's do that. So to do that, you just use the var function, so which we see here, and we can be able to do that, and we can see this is the variance. This is how far this how far each and every value is from the mean. Standard deviation just generally would be the square root of variance. So it would be just this, but now the square root of variance. So we can do that using the std function. And something to note also, if the data points are further from the mean, there's a higher deviation within the data set. Thus, the more spread out the data and higher the standard deviation. So if what that means is just that if data is much more spread out, it means that you'll have a higher standard deviation. But if data is much more compact towards the mean, then the standard deviation would be smaller. So in our case here, means data is actually much more spread out. Range, sometimes you might want to determine the range. This is also important when we are working with outliers, because sometimes we want to define outliers as those points that are outside the 75th percentile, or even just which would be away from the 50% of the records that we are working with. So how do we calculate range? We use max and mean functions. So we apply the same to the same variable, credit amount, the same here. And then the range is usually mean minus max minus mean, so which we do here. All right, so That's range, quantiles. These are just the so when it comes again to working with outliers, we might need to calculate interquartile range, which is again a measure of variability around the median, and we can do that using what are called quantiles. So we can calculate different quartiles. So for instance, the 0.25 for the 25th percentile or 25th quartile percentile, 0.25 is 0.5, and there's also 0.75. And to be able to do that, we use the quantile function, and we apply it to the column that we want and define the different quantiles that we want. So in our situation, let's do that, and you can see what we have here. Skewness, we might want to measure the symmetry of the variable that we're working with to understand whether the data set is negatively or positively skewed. So in our situation over here, we have a positive value generally, which just means that our data is positively skewed. It's not normally distributed. Kurtosis is another statistical measure that we can use to describe the degree to which cluster scores in the tails no. So sometimes you might want to also okay, all right. So sometimes you might also want to also understand the degree to which the data points are clustered in the tails, or the peak of a frequency distribution. So or whether it's on the tail or at the peak of it all. And we can use what is called kurtosis. And positive values of kurtosis indicate that the distribution is peaked and it has maybe thick tails. So in our situation, I think we had created something of a histogram, like something over here. Sometimes you could have a bigger tail on this side or on this other side. So kurtosis would actually give us an indication of how the points are actually how they actually appear along the tails or the peak of the frequency distribution. So positive values would indicate that a distribution is peaked and possesses thick tails, and negative values would just indicate that a distribution is flat and has like really thin tails, which just means there are not many points on those particular tails. So if the kurtosis is closer to 0, then a normal distribution is often assumed. But in our situation over here, we have a positive value, which means that the distribution that we are working with has some thick tails, which means there are quite a number of points towards the very end. Lastly, I think we had already performed this. We had already displayed summary statistics of a variable earlier, which you can do using the describe method. All right, so work on the challenge and then come back and we'll continue. By the way, don't forget to verify your solution. Once you're done, we'll continue with bivariate analysis. Now, moving on to bivariate analysis, the types of techniques that we can perform here would be either scatter plots, Pearson correlation coefficient, or line graphs. So starting off with scatter plots. So a scatter plot would allow us to determine whether there are relationships. There's a relationship between two variables, and a scatter plot would just it just tells us that. So let's first of all load the data set that we want to work with. We have this data set that contains R&D spend, administration, marketing spend, state, and profit. Sometimes and we might want to determine whether R&D and administration costs are related, or marketing spend and administration costs are related, or profits. Sometimes that can be useful because you might know that maybe actually R&D spend and profit are related. So we should put more money in research and development. That would mean we get more profit in the end. So that could mean that sometimes you might realize those are hidden um, insights that would be important in your analysis. So to be able to do that, we create a scatter plot that will just give us an idea of what that would happen. So let's actually do that. We will create a scatter plot. We will use we will use pandas. We won't use matplotlib or seaborn, which we can use. But you can always consider going through those courses if you want to just explore that further. So startup df is the data frame that we are working with. Plots, that's the plot function from pandas, and scatter function, and inside we pass the first argument, which is what we want on the x-axis: R&D spend, research and development spend, and profit on the y-axis. And we add a title to our visualization using Plotly, with not Plotly, Matplotlib, and show the visualization. And as you can see here, apparently, um, as the as you even can interpret, as the values of R&D spend go high, the profit also increases. So which means there's a correlation between those two variables. It could mean that as more profits, as you spend more on research and development costs, maybe products, etc., profits actually tend to increase. Of course, there are other reasons why. It's not just for the sake, you can't just put in money and expect profit, but there are other systematic reasons, that there are other considerations that would actually contribute to this pattern in real life. So that is, which is worth also exploring. So that is something. But if you have points which are just not moving towards the far right, but they're just stagnant, let's say points just come from this particular side towards this end, if they came from this end to this end, and it would show that as you increase research and development spend, you wouldn't find profit going up. So it would mean that that doesn't make sense. It would mean actually that those two variables are not correlated. So you can say that when you put in more money, then profit increases. But again, there are other considerations that would also come in handy when you're making that conclusion. Could be team. Maybe you might have a poorly performing team. Yes, you're putting in a lot of money, but still again, profit wouldn't increase. That is, that is also another factor. Again, you could also have points coming from this other side towards the very bottom. In such a situation, again, could say that those two variables are correlated. It could be that as profits reduce, research and development spend increases, which doesn't make sense, but in an organization, does it? Profit reduces, research increases. It could actually, in that situation where you have a poor team, yes, you're putting in more money, but again, profit just reduces. Okay, maybe, I don't know, I'm not sure. It depends also on different factors as well. So that's how you just generally interpret a scatter plot. Yes, I even mentioned this. This does not mean causation. One would need to investigate further to determine whether valid. All right, work on the challenge and then verify your solution, and then we will continue. Person correlation coefficient. So sometimes we might want to assign a number to the degree to which these two particular variables are are related or correlated. So we might decide to maybe give it a value between -1 and 1, which is what I was explaining earlier. So values, like in our situation over here, you'd actually find a value closer to 1, which might be 0.8 or 0.9, which would mean that there's a higher positive correlation. If it's on towards 0, then there will be no correlation at all. So let's just create a let's calculate the person correlation coefficient for those two variables. So we will first of all define the variable that we want, the first one, and we want to create a correlation coefficient, or we want to calculate the correlation coefficient between this variable, R&D spend, and startup marketing spend. And the method, the correlation method we want to use is person. There are different correlation methods with different use cases, but for our concern, it's the person correlation coefficient. Using now that, and then we store the outcome of that, which is the outcome of what we want is that, and we get 0.72, which just generally means that those two have a positive correlation. Normally greater than, a correlation coefficient greater than 0.5 means the two variables have a strong positive correlation. Correlation coefficient less than 0.5, from 0 to less than 0.5 means that the two variables have a weak positive correlation. A correlation coefficient of 0 means that the two variables are not correlated at all. A correlation coefficient of negative 0.5 and 0 means that the variables, the two variables have a weak negative correlation. And a correlation coefficient between negative 1 and negative 0.5 means that the two variables have a strong negative correlation. So we can also do the same thing for the entire data set. Here we have only two variables, that's R&D spend and marketing spend, but we can do that for the entire data set because sometimes you want to save on time. So it will, so this particular, when we use when we apply core function to the actual data set, we actually get the percent correlation coefficients for the variables, the numeric variables within the data set. So if we run this, this is what we are going to get. You can ignore this. This, you can just ignore that. This is our table, and our table just gives us an idea of what it gives us those values. So when you look at R&D spend versus administration, they have a weak correlation coefficient. They have a weak correlation coefficient. R&D spend and marketing spend, they have a strong positive correlation coefficient value. R&D spend and profits, they have quite a strong correlation coefficient. So this just gives you a good idea, and you can even go further and visualize this particular table using a heat map. So we use Seaborn, then the heat map function. We just pass the data that we have, startup, DF, correlation, and we annotate it. We just want these numbers to appear in the visualization, and we want to define the minimum value in terms of colors to be at -1 and maximum at +1, just 1. And we should be able to see that we now have a visualization. So you can see whatever is a bit more lighter actually is what is representative of a strong correlation coefficient. So you can see this, just this, and this. Whatever is a bit darker has actually negative or no correlation at all. All right, work on the challenge and then we'll continue. All right, moving on, line graphs. Sometimes we might want to, again, examine the relationship between two variables through the use of line charts. So sometimes we could decide to create a line chart and also understand the trends for that. So let's first of all do this. We are going to load this data set, Candy production data set, and we store it in Candy DF. And then what we want to do is only work with 26 records with the year 26 upwards. So we apply some condition. So in our situation here, Candy DF, so Candy DF observation date, which is the year that we want, greater than 2015 12/01 towards the very end, so that we start having the records from January 2016. So we store the outcome in Candy 26 plus DF and preview the first 5 records. For just understanding what's happening, this is what we have from 2016 onwards. This is the first 5 records, and then we can plot a line graph. We're going to just use pandas. You can still use matplotlib or even Seaborn, but we just use pandas for ease of learning. So plt.line plot.line, we apply this function, and then we pass the observation date as x, and the y to be now on our y. We want to have this particular IPGN 3133N, which is just generally, it represents it doesn't show here, but I think it's something to do with candy production. But the most important thing, what we're really interested here, is just to understand the trend here over time, which we can see from 2016. We go downwards, it goes up, downwards, up, downwards, up, downwards, up. Yeah. All right, so that's generally it. I hope you were able to have gone through this section. So again, with ease, go through the challenges, and then once we are done, we'll continue to the next section. Now, moving on to the next section. Now, this is now going to be the project that you're going to undertake. The idea is for you to work on this project. The management of a certain NGO hospital would like to have a product developed that would predict whether a person has diabetes or not. And you're going to use some data sets that we have provided. And once you have done that, you can use the solution notebook to just check your understanding of the content itself. So the idea here is to just ensure that you have a good understanding of how you can apply the skills that you have been able to learn and be able to work on a real life project. We've also provided a guiding notebook which has just steps that you can take to provide a solution for this project. It will take you through the entire process. There are areas where we have created, we have put some code because sometimes we realize that it may be helpful to do that. We don't want you to start learning and thinking about that. To work on this project, you need to think about concepts that we haven't taught in this workshop, in this course. So in order to ensure that you're able to go easily through this particular project, you'll go through step-by-step process of just applying the techniques using the CRISP DM methodology, which is normally used when it comes to data analysis or data science projects. And the idea is for you to just apply those concepts that we have gone through. Sometimes you might find we have applied a bit of that, and you can actually do the same. And you might learn one or two things from actually working on the project. And once you're done, you can just check your solution through the solution notebook for the project that we have provided to just have a good understanding of the expectations. So that's it generally. I hope you have learned much so far and are ready to continue this learning journey. So this is just one of those many courses that you might end up undertaking when it comes to learning data analysis as data science, and it would be helpful for you when it comes to working on projects, even much more specific projects, such as when you want to work on the creation of machine learning models. So this is what we've covered, are techniques that will be important for that. If you realize that maybe this might have been a bit of a tough course, you can consider going through some other courses that we have for beginners, starting off from introduction to Python, going to data analysis with data wrangling with Python, data analysis with Python, then going to matplotlib, data visualization with matplotlib, and then data visualization with Seaborn. Once you have done that, then you should be okay to now undertake the workshop or this particular course. That's it. That's it for this workshop. Hope you learned a lot. If you have any questions, feel free to ask them in the chat or even the comment section for this course. And if you are if you might have maybe some ideas of what we can do in terms of have future courses, you could also post them in the chat, and also share the video with persons that you think would be much more interested in undertaking the course and gaining value from it. All the best in your learning journey, and see you in the next course, which should be much more of, in maybe regression. So working with machine learning models now. You should now be able to go into that. All the best in your learning journey.